Hi everyone, welcome to lecture 11 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover ionic compounds and we will look at the formation of ions from non-metals. So we now look at how to form ions from non-metals. Recall that nonmetals gain electrons from metals to form anions. So nonmetals accept electrons to achieve the octet arrangement. The octet arrangement is the preference of elements starting from carbon to have 8 electrons in their outermost shell. So non-metal ionic charge can be 3 minus, it can be 2 minus, or it can be 1 minus. Right, we now look at how fluoride ion is formed. Fluorine has atomic number 9. Its electronic configuration is 2 electrons in the first shell and 7 electrons in its outermost shell. This is fluorine with 7 electrons in its outermost shell. When fluorine gains 1 electron, its electronic configuration will be 2 electrons in the first shell and 8 electrons in its outermost shell. This configuration corresponds to that of neon, which is a noble gas. In this way, fluoride ion has achieved the octet arrangement because it now has 8 electrons in its outermost shell by gaining this 1 electron. Fluorine has 9 protons and 9 electrons, so the overall charge here is 0. But fluoride ion that has gained 1 electron has 9 protons and 10 electrons. So the overall charge here is 1 minus. So this is how we arrived at negative charge for fluoride ion. We now look at how chloride ion is formed. Chlorine has atomic number 17. Its electronic configuration is 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in its outermost shell. So this is chlorine with 7 electrons in its outermost shell. When chlorine gains 1 electron, its electronic configuration will be 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in its outermost shell. So this electronic configuration corresponds to that of argon, which is also a noble gas. So in this way, chlorine has achieved the octet arrangement because it now has 8 electrons in its outermost shell, and we call this chloride ion. So chloride ion has achieved the octet arrangement. So chlorine has 17 protons and 17 electrons. The overall charge here is 0. But chloride ion has 17 protons and 18 electrons. So the overall charge is 1 minus. This is how we arrive at this minus for chloride ion. We now look at how oxide ion is formed. Oxygen has atomic number 8. Its electronic configuration is 2 electrons in the first shell and 6 electrons in its outermost shell. This is oxygen, having 6 electrons in its outermost shell. When oxygen gains 2 electrons, it will achieve the octet arrangement, and it will have the electronic configuration: 2 electrons in the first shell and 8 electrons in the second shell. This configuration corresponds to that of neon, which is a noble gas. Oxygen atom has 8 protons and 8 electrons, so the overall charge is 0. But oxide ion has 8 protons and 10 electrons. The overall charge here is 2 minus. So this is how we arrive at these 2 minus for oxide ion. Let's look at some examples. So these are all anions. Let's now look at how to name these anions. So N3 minus is known as nitride. O2 minus is known as oxide. F minus is known as fluoride. P3 minus is known as phosphide. S2 minus is known as sulfide. Cl minus is chloride. I minus is iodide. Br minus is bromide. We now look at how to name binary covalent compounds. Recall that nonmetals do not give out electrons. Only metals give out electrons. So nonmetals always form covalent bonds as they share electrons to achieve inert gas configuration in order to be stable. Example is carbon, which has 4 electrons in its outermost shell. So it shares its 4 electrons with 4 hydrogen atoms to complete its octet. Okay, recall that examples of metals are sodium, copper, silver, magnesium, gold, potassium, calcium. Examples of metalloids are boron, silicon, arsenic, antimony, polonium, germanium, selenium. Examples of nonmetals are nitrogen, oxygen, sulfur, chlorine, neon, argon, phosphorus. So it is important for you to remember these examples. Right, so if you are asked to name 2 metals, the first thing you do is to name each element. The second thing you do is to end the last name with IDE. The last thing you do then is to add prefixes to show more than one atom. The prefixes in use are: mono is used for 1, di is used for 2, tri is used for 3, tetra is used for 4, penta is used for 5, hexa is used for 6, hepta is used for 7, octa is used for 8, nona is used for 9, and deca is used for 10. Let's look at some examples on how to name binary compounds. CO, first you write the first element's name, which is carbon. We write mono because it's just one oxygen atom. And then we end the last element's name with IDE. So CO is carbon monoxide. For CO2, it is carbon dioxide, di, because there are 2 oxygen atoms. PCl3 is phosphorus trichloride. CCl4 is carbon tetrachloride. So always you name the first element and the last element's name ends with IDE. So 4 chlorine atoms, that's why we put tetra here. And N2O is dinitrogen monoxide. So 2 nitrogen atoms That's why we put di, and mono, one oxygen atom. So this is how to name binary compounds. So let's look at some practice examples. P3O5, what is the correct name? The correct name is triphosphorus pentoxide because we have 3 phosphorus atoms and 5 oxygen atoms. Number 2, Cl4O5 is tetrachlorine pentoxide. Br4O5 is tetrabromine pentoxide because we have 4 bromine atoms and 5 oxygen atoms. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I'm gonna see you in the next lecture.